Welcome back to Maths with Mrs. J. We're now ready to learn about composite functions, otherwise thought of as a function of a function. This is where function notation and an understanding of that is very, very important. Just recall from a couple of videos back where we learned about function notation, we learned that if we have something written in the form of f of x equals 3x squared plus 2x minus 7, that means whatever you have in the brackets here, so if you had f of 2, that means you're going to sub that in wherever you see an x. So 3 times 2 squared plus 2 times 2 minus 7, which is what, 12, 16, which is 9, right? F of anything is 3 times that thing squared plus 2 times that thing minus 7, whatever that happens to be. Now that might even be an entire other function. Might be an expression involving x. We're just going to sub it in just like we normally do. There are 3 main ways that I've seen people do write a composite function, f of g of x. My preferred way is the first way because it really sort of points out, I guess, the fact that you're subbing in g of x in place of x. Some people use fg of x. Some textbooks use fog, f of g of x. It doesn't mean fog. It probably is a bit of a fog when you start learning how to do these things, but it doesn't mean fog. It means f of g. My preferred way, whatever the way you start doing it, is to put it into this version as you're working it through. I'll do some examples. The first few will be relatively simple and then we'll work up in difficulty. Our first example here, we've got f of x is 4x and g of x is x minus 3. I'm wanting to do f of g of x and g of f of x just to get some practice in there. Well, f of g of x, f of x is 4x. That's what the rule says. So f of g of x will be 4 times g of x, right? It might help to use colours to help you just remember this is like your x. Now we can sub in the fact that, well, g of x actually has a rule that we know. G of x is our x minus 3. Now you can leave it like that if you really like, or I would be inclined to expand that out. So f of g of x is 4x minus 12. Now g of f of x, same sort of thing, but what we're doing now is we're subbing f of x into our g of x rule. G of x says x minus 3. So g of f of x will be f of x minus 3. F of x was just our 4x minus our 3, and we're already done there. Sometimes there'll be a fair bit of rearrangement necessary. Other times it'll be very simple like this. Okay, ready to move on. Let's try some slightly harder examples. Okay, so here we have a quadratic function and a linear function. We want to do f of g of x and g of f of x and see what we get. So f of g of x means wherever we see an x, we want to do g of x squared. So it's going to be g of x all squared plus our 3. What was g of x? Well, g of x is x plus 5. Now, depending on what you're using it for, you might even prefer it in that version because that would then help you find the turning point and that sort of thing. But we might be inclined to expand that out and gather up like terms. You get 25 plus 3 is 28. So that's your f of g of x there. G of f of x means you're going to sub f of x into your g rule. So it's going to be f of x plus 5, all right? G of x is x plus 5, so G of f of x is f of x plus 5. F of x was our x squared plus 3, and just gathering up our constant terms there, we get x squared plus 8. So G of f of x is x squared plus 8. Okay, next one, f of g of x. Means we're going to sub g of x into our f of x rule. So it means we're going to take the square root of g of x. Well, square root of g of x is just square root of x minus 1, and we're already done. G of f of x means we're going to pop f of x into our g rule. So it's going to be f of x minus 1. F of x was root x. And that's it. There's nothing really we need to do as far as tidying that up. That's already perfectly fine as is. Alrighty, so let's do 2 more that'll be a little bit more tricky, but that's okay. Let's have a look at question 4. So we have an example here where we are going to have to do a bit of algebraic manipulation to tidy this up as we go. If we want f of g of x, that means everywhere in our f of x rule, I'm going to put g of x. Okay, so I'm going to have 8 times g of x plus 1 over 4 times g of x minus 2. Now we can sub in what g of x was. G of x was just 2x minus 1. 4 times 2x minus 1 minus 2. Just expanding and collecting like terms. 16x minus 8 plus 1, so 16x minus 7. 8x minus 4 minus 2, so 8x minus 6. So that's f of g of x. I'm going to do g of f of x here because I've run out of room there. So g of f of x means into your g of x rule, you're going to pop f of x. So it'll be 2 times f of x minus 1. All right, so we're going to have 2 lots of this expression, 8x plus 1 over 4x minus 2 minus 1. Okay, this is actually going to cancel out. The 2's will actually cancel here because what you've actually got, if you take out a 2 here in the denominator, you'll notice that those 2's will cancel. So we're going to get that minus 1. So we're going to pop this all over our 2x minus 1. And we're going to end up with 6x plus 1 plus 2 all over 2x minus 1. That's a little bit fiddly, but if you just sort of keep a level head, you'll be perfectly fine there. Right, I'm just going to remove that so that I've got a bit of extra room to work with this next one. This one here, I have deliberately picked this one to lead on to our next video, so bear with me. All right, f of g of x. Okay, f of x is 5x plus 3 over negative 7x plus 2. So it's going to be 5 times g of x plus 3 over negative 7 times g of x plus 2. Right, what have we got? So we've got 5 times 2x minus 3 over 7x plus 5 plus 3 over negative 7 times 2x minus 3 over 7x plus 5 plus 2. What are we going to do? Well, I'm going to put this over our 7x plus 5, that as well, and then get rid of our 7x plus 5. So we're going to end up with 5 lots of 2x minus 3 plus 3, 7x plus 5, all over. The 7x plus 5s will cancel, and you'll be left with negative 7 2x minus 3 plus 2, 7x plus 5. All right, numerator, you're going to get 10x plus 21x, which is 31x, minus 15 plus 15, so they go. Denominator, negative 14x plus 21 plus 14x plus 10. So that's over 31. 31x divided by 31 is x. Interesting. All right. Let's do the other way around. Okay, so g of f of x means everywhere in your g rule, you're going to put f of x. So you're going to have 2 times f of x minus 3 over 7 times f of x plus 5. Your f of x was this expression here, so we're going to have 2 times 5x plus 3 over negative 7x plus 2 minus 3, all over 7 times 5x plus 3 over negative 7x plus 2 plus your 5. All right, I'm going to pop everything over that negative 7x plus 2 and then cancel them. So we're going to end up with 2 times 5x plus 3 minus 3 times negative 7x plus 2 all over 7 times 5x plus 3 plus 5 times negative 7x plus 2. Those cancelled because you turn the second one upside down, cancel. You're going to end up with 10x plus 21x, which is 31x, plus 6 minus 6, so that goes. 35x minus 35x, that goes. That was a 3, wasn't it? So we've got 21 plus it, which is 31, which is x. Interesting. What we've actually found there is that these two functions are inverses of each other. They undo each other. If you have a function such that if you do one function and then you do the other function after it and you get back to x, that counts as an inverse function. These are inverses of each other. Because if you do f of g or g of f, you just get back where you started to an x. All right, and that's going to be what we're going to be doing in our next video, learning how do we actually come up with the expressions for our inverse functions and relations.